Welcome to Think Global Education Services. Today's topic is Universal Law of Gravitation. It is also called as Newton's Law of Gravitation. Let us take two objects with mass m1 and m2, and the distance of separation from the center of mass m1 to center of mass m2 is r. And according to Newton's Law of Gravitation, since these objects have masses, there is a force of attraction between these two objects. The force of attraction is given by letter F, which is inversely proportional to the square of the distance between them. So it is inversely proportional to the square of the distance between them, and it is directly proportional to the product of their masses, m1, m2. So the force is given as m1, m2 divided by r squared. Now we can equate this force by introducing a constant g. This is called as the universal gravitational constant, and g has a value of 6.67 into 10 to the power of minus 11 Newton meter squared per kilogram squared. This is the Newton's law of gravitation. Now, using this law, especially this formula, we can find out what is the gravitational field strength of any mass that produces gravitational field. For instance, let's take Earth. And if you want to find out the gravitational field strength of the Earth at a position from the Earth, from the center of the Earth, we can find out using this formula. Now, in case here, let us find out the gravitational field strength using the formula. Let us take that the gravitational field strength near the surface of the Earth is given by the letter g, which is called as the acceleration due to gravity. And normally when we measure weight of an object is given as a force. The weight is equal to mg. So there the g is the acceleration due to gravity, and we can find the g as, weight is a force, so we can write that w as f equal to mg, which implies g equal to f divided by m. So here we have an f, so if we divide that f by m, so we'll get g m1. Let us take this is m1, m2 by r squared divided by m1, so we'll get g m2 divided by r squared. Now in case, let us take this as Earth. So mass of the Earth is represented as me, and let's take this is the radius of the Earth, and here a person is standing. You want to know what is the gravitational field strength from the center to this point, and should be felt by this person. So it is given by the field strength is given by the letter g, which must be equal to capital G, mass of the Earth, divided by radius of the Earth squared. And mass of the Earth is a value which is equal to 6 into 10 to the power 24 kilograms. So mass of the Earth is equal to 6 into 10 to the power of 24 kilograms. And radius of the Earth is equal to 6.4 into 10 to the power 6 meters. Now if we substitute that values in the formula, we will get small g, which is acceleration to gravity, is equal to, and the value of capital G is here, 6.67 into 10 to the power minus 11 multiplied by 6 into 10 to the power 24 divided by r squared, so 6.4 squared multiplied by 10 to the power 12. Since 10 to the power 6 squared is 10 to the power 12, so the numerator we can multiply these two values and divide by 6.4 squared. So 6.67 multiplied by 6 divided by 6.4 squared multiplied by, and here we have to subtract these two values. We'll get 10 to the power 13, and if you subtract 10 to the power 12 from 10 to the power 13, you will get 10. 10 to the power 1, so that is 10. And here, as you can see, from these values, they are all closer to 6. Let us say this is 6.6 and this is 6 and this is 6.4. So we can write that as 6.6 into 6 divided by 6.4 into 6.4. As you can see, we can say this is also 6.4, and we can also include this as 6.4. So then everything will get cancelled and we'll get 1. So something 1 point some value. So that will give us, or we'll get 0 point some value. So that will make this value to be equal to, g is equal to 9.81 meter per second square. So g as a unit of meter per second square, since it is the acceleration due to gravity. So nearer to the surface of the earth, all the objects feel the same field strength. Now, in case if the object is at a distance of, let us say, 10 kilometers from the surface of the earth, so we have to change the distance here, r squared value to 10 kilometers. As you can see, we have kept the distance as 6.4. So we will have to just add 10 kilometers to the radius of the earth. So we have the radius of the earth 6.4 and 10 power 6 kilometers. So plus 10 into 10 to the power 3 meters. So this would be the change that we have to introduce into this formula to find out the gravitational field strength at a distance of 10 kilometers from the surface of the earth, which would be a very different value. And as we know that, looking at this formula, you can see that looking at this relationship between the force and the radius, force and the distance between the objects, you can see that the force will decrease, the distance increases. As the distance increases, the centripetal force, or the gravitational force here in this case, decreases. And this gravitational force works as a centripetal force because it makes the object to move in an elliptical orbit. In case of Earth, it moves in an elliptical orbit. And we can equate mv squared by r, that is the centripetal force, with the gravitational force to find out the unknown values. For instance, the mass of the earth, radius of the earth, we can use that equation to find out the mass and the radius of the earth. And thank you for watching.